So, Gillian, you want to give them a little more time for people to come, or you can start whenever you wish?
Can we wait a little bit longer?
Yeah, certainly.
Since we know that Graham and Axel and other people are coming back.
Yeah.
Okay.
Now you can take the opportunity, since you were the one that were here on time, to ask any extra questions. No. They tell me that they were actually taking extracurricular, like a seminar on logic.
That's cool.
And they come all the way from the next state, which is about like 7 hours to get here.
It came 7 hours to get to this workshop?
Only 3 hours. It's all the way up to the northern, northwest side of the city. In it's past Satellite City, isn't it? Almost in Jardines de San Mateo, St. Matthew's Gardens. Yeah. So it can take easily 3 or 4 hours to get down here.
They must really like logic.
Do you? Do you really like logic that much?
Yeah.
Yeah.
And they have a special group called the Logic Quarry, La Cantera, where they put together materials. They have the games there, don't you? The computer games.
The Logical Beast.
The Logical Beast. Yes.
I haven't heard about that game.
Propositional.
Oh, great.
Oh, that's fun.
Beautiful philosopher. Who is Gillian Russell? Her work.
This was in New York. That photograph. This was at the Kripke Center. Oh, I've never seen this.
Is that your book?
That's so nice.
And it is called.
Since it's in Spanish, I can't understand a word, so I could say anything.
It is the quarry, La Cantera.
Okay. I should look for that.
It's only nice, yes.
Thank you. That's nice. Here they come.
All right.
Luis, is Axel coming also? So, is it okay to come more lights?
Oh, yeah.
Sure. Okay. Thank you so much for coming to hear Gillian Russell's lecture. Without any further ado, she's going to give a presentation, and then we'll open the floor for any questions or comments that you might have.
Okay,
Russell?
thank you. Since I am the last speaker, it seems like a good time to thank the organizers of this conference. So people come to mind, especially Louis and Maria from yesterday, although I know she's not here today, but also everybody who's been organizing and helping, and all the people who've chaired sessions. Just wanted to say thank you. So maybe we can clap. Okay, so my talk is called "Could There Be No Logic?" And it's about, right? So kind of a crazy idea that maybe there is no logic, right? It's a view that would quite naturally be called logical nihilism. And so I have this name for it on the board, logical nihilism. Logical nihilism is just the view that there is no logic. And the particular version of it that I'm going to discuss is the view that there are no laws of logic, where the kind of thing that would count as laws of logic, if there were any, would be things like maybe the law of excluded middle, or we've got modus ponens here, right? So if you're a logical nihilist of the kind that I'm interested in, if you think about the law of excluded middle, they say, nope, that's not a law. You think about modus ponens, they say, nope, that's not really a law of logic. There are lots of views, maybe some of them are slightly crazy views, which reject one or two of those laws, right? So if you're an intuitionist, then you don't think the law of excluded middle is a good law of logic. Or if you're a dialetheist, you don't think explosion, the idea that you can get anything from a contradiction, is a good law of logic. But one of the things that makes nihilism sound so wild to start with is that they go further than all those people. They say not only like the law of non-contradiction, the law of excluded middle, or modus ponens, or disjunctive syllogism, any of those things that you like, even worse. Like, what about things like conjunction elimination? So from a conjunction, you can get one of the conjuncts. They say, nope, that's not a law of logic. And even identity, right? So even from phi, you can get phi itself. They say, no, that's not a law of logic. Okay, so you might wonder why I'm talking about such an obviously ridiculous view, right? And one of the reasons that and I think other people have become interested in this view recently is that it's come up in the literature on logical pluralism. So here's one way in which that happens. Logical pluralists say that there is more than one correct logic, right? So maybe they say intuitionistic logic and classical logic, they're both good. Or intuitionistic logic and paraconsistent logics, they're both good, right? And one of the ways they justify this kind of view is they say, okay, here's what it is for an argument to be valid. All right, so for one of these kinds of things to hold, it has to be the case that in any case where all the premises are true, the conclusion is true as well. And then they say, okay, so that's what it means to be valid, but case is kind of ambiguous, right? So by case, you might mean, say, possible worlds, or you might mean first-order Tarski models, or you might mean possible worlds including a bunch of other weird impossible worlds, or you might have worlds that are not complete. So there's all these different things people might mean by case. And one kind of pluralist thinks, well, you can precisify that word case in lots of different ways and get lots of different perfectly good conceptions of validity. And so if you precisify case one way, for example, you might get modus ponens, but if you precisify a different way, then you might not get it. Okay? So different logics, depending on what sort of case you're talking about, and so more than one kind of correct logic. That's kind of one pluralist line. But not everybody's a logical pluralist, and one way in which logical monists, and I think Graham is in this camp, have responded to this kind of idea is to say, look, logic is not supposed to depend on what sort of case you find yourself in. You're not supposed to have to like add an extra premise about what sort of cases you're dealing with or what sort of cases are relevant. If something's really a law of logic, it's supposed to work in every case, right? And this fits very well with a sort of very old idea about logic, and you find versions of this in Kant, you find versions of this in Frege. It's the thought that logic is supposed to be perfectly general, right? It's supposed to hold for every case. It's not about some particular subject matter. It's not about particular kinds of cases. And so the only laws that the pluralist accepts that are really laws of logic are the ones that work for every case. So, you know, imagine the pluralist says, okay, I like intuitionistic logic and I like classical logic, so I want to say both of those are correct. And the monist says, no, it's only the laws that work in both of those logics that you can have. They're the only the ones that are the real laws of logic. To which some pluralists have responded, if that's the move you make, there's nothing left, right? There are no laws of logic that feature in all the good logics, right? There's nothing at the intersection of all the good logics. Actually, strictly speaking, sometimes they back off that very extreme claim. So they might say, if you make that move, there's nothing useful left. Maybe all you get are, say, conjunction elimination and identity, but you don't get any of this useful stuff over here. So that the view you're left with is kind of a really, really weak logic, too weak to be useful. So we could maybe distinguish two kinds of view. One of them would be logical nihilism, no laws of logic at all. And the other one we might call logical minimalism, which is, yeah, there might be a few laws of logic, maybe identity and conjunction elimination, but they're too weak to be useful, right? And a lot of the things that seem unattractive about logical nihilism, and I think logical nihilism is unattractive if you like logic, as I know that many people here do, because you came, was it 7 hours to come and see this workshop? So if you like logic, logical nihilism sounds kind of bad, because it means you don't get to do any logic, right? But logical minimalism has a lot of the bad consequences that logical nihilism has. So anything that you might have wanted to do with logic, if you wanted to do some like useful meta theory, or if you wanted to give foundations for arithmetic, or if you thought like Tim Williamson, you could do interesting metaphysics by doing logic, coming up with the best modal logic would be a good way to learn about necessity. Well, you know, it's going to turn out you just can't get very far. Right? So a lot of this talk will be about logical nihilism, but I'll often kind of include with logical nihilism this very similar view, which is logical minimalism, just very weak laws of logic. Okay, so from that debate between the pluralist and the monist, we can extract a kind of argument for logical nihilism. Right? So the argument goes like this: in order to be a law of logic, a principle would have to hold completely generally. Like, for example, for every case, no matter what kind of case you were thinking about, right? But no laws hold completely generally, right? There aren't any principles that hold completely generally like that, so there are no laws of logic, right? That's kind of the sketch of how an argument might go. Now, the pluralist thinks this is a reductio, right? What they want to happen is they want the monist to back off that claim about generality and then admit that, you know, laws don't have to hold completely generally. They could hold for these cases or hold for these cases. But the last thing they expect somebody to do is say, oh, you're right, logical nihilism is true, right? There's no logic. But in this talk, I want to take seriously the idea that logical nihilism could be true. Okay? So that's one of the things that's going to be going on. Here's basically the structure. I'm going to talk about, like, more carefully exactly what the view comes to. So I'm going to talk about what a logical law would have to look like and what, when we write one of these things out, what it really means, like what would have to be the case for it to be true. Okay. And then when I've done that, I'm going to talk about this objection to logical nihilism that I hear if I talk about it without mentioning that objection, which is the idea that maybe logical nihilism is self-defeating, right? So that's sometimes a reason that people use to say, oh, we don't have to worry about this view. It's self-defeating. It takes care of itself, right? And then I'm going to give you an argument for logical nihilism, right? And the way that's going to work is I'm going to try to make it more plausible that there are counterexamples to every law, that no law holds completely generally. And so really the main things I'm going to do is I'm going to give you some counterexamples to conjunction elimination and to identity, right? The counterexamples are going to be a little bit odd, right? There's going to be stuff that we can argue about with the counterexamples, and maybe we'll end up doing that. But the way I'm going to finish this talk is I am going to suggest what I think is the right response to this argument for logical nihilism, right? The right response to these weird kind of counterexamples. And I'm going to draw on some work by Lakatos, who has similar things to say about things in geometry. And I think that what he says in geometry makes a lot of sense for logic as well. So I'm going to suggest a solution for the problems that I've raised. Okay, so here is part 2, I guess, as we've done the introduction. And the question is, what is logical nihilism? Okay, so I'm going to deal with this in 2 parts. I'm going to talk about the form of logical laws, right? What kind of shape they should take, and then, I guess, the semantics. by which I mean just, what has to be the case for one of those laws for something of that form to be true. So here's like a first really naive thought you might have about logical laws. Maybe something's a logical law if it's a claim that holds in virtue of logic alone. That's the kind of thing that people call a logical truth, right? Just in virtue of the meanings of, say, the logical expressions, that's enough to make it true. And so that would mean things like this on the top line here, right? So we've got the law of excluded middle, phi or not phi. You might think that holds in virtue of logic alone. We've got if phi, then phi. And I'm sure you can think of other examples of things that would be logical truths, right? But, what was I going to say? Oh yeah, so there are some people who don't think there are any laws like this, who we still wouldn't want to call logical nihilists. Okay, so here's an example. If you are a strong cleaning logician, so you accept this logic that's sometimes called K3, then you think that, well, here's one way to do it. There's more than two truth values that are possible values for the variables that go in here. So it's not just that this could be true or it could be false. It might also be neither, right? So yesterday, Graham was talking about the idea that some sentences might be both true and false, right? This is the idea that some sentences might be neither true nor false. And there are standard philosophical motivations for this. So people sometimes talk about non-referring terms. So if you have a sentence like Pegasus is tall, right, and you think Pegasus doesn't pick anything out, some people think that sentence gets no truth value. Or there are certain cases involving vagueness. So if I lay out 100 cards on the table in front of me, and the one on the far left is bright, bright red, like as red could be, and the one on the far right is clearly orange, it's not red at all, right? And then they gradually fade from red to orange. Some people think if you pick a card in the middle, and you look at the sentence, this card is red, it has no truth value, right? This card is red, true. This card is red, false, but somewhere in the middle, there might be some cases that don't have a truth value. All right, there are also examples of like future contingents, so things that haven't been determined yet, like there will be a sea battle tomorrow, right? If that could go either way, it could turn out to be true, it could turn out to be false. Some people think that right now it has no truth value, right? Anyway, so suppose you're one of these people that thinks that some sentences can have no truth value. Well, there's a standard way of figuring out what the truth value of this whole thing is if this gets U, meaning no truth value, right? Here, they think that the negation of something that's undefined, right, is also undefined, so this is undefined. And if you disjoin the result, you get something that is undefined, and so it's not always true. Sometimes it gets no truth value. But it turns out this works for every classical logical truth. So if you're that kind of logician, you think there's no sentence that gets true on every interpretation, gets true no matter what, and so you think there are no logical truths. But you're not a logical nihilist, because the K3 kind of logician can still accept modus ponens, right? Okay, so here's a natural way to sort of get a bit more careful about what we mean by a logical law. It doesn't just have to be something like this. It can be something with things on the left-hand side of the turnstile, like things on this row, okay? So logical laws can look like this, they can look like this, and now there's no danger of the K3 logician looking like a nihilist because they accept some logical laws, namely ones with stuff on the left. Okay, but once you've done that, you might think, well, why stop here? Why not allow more complicated things to count as logical laws as well? So here's a couple of examples. If from some set of premises gamma, you can get phi, then from gamma, along with some additional sentence psi, you can still get phi. All right, so that's sometimes called thinning. Okay. Or this one here, if gamma entails phi, and delta together with phi entail psi, then you can leave out the phi and just take the gamma and the delta together, and those will give you psi. Okay, so you can kind of cut out the thing in the middle, and so sometimes people call this cut. Okay, so maybe they should be logical laws as well. The way I'm going to understand logical nihilism things like this are not logical laws, right? They don't have the right form. Here's why I'm going to say that. I think a good way to think about logical nihilism is it's the view that the extension of the entailment relation is empty. So for any set of premises and conclusion whatsoever, it's not the case that the entailment relation holds between them, right? So the extension of that relation, there's nothing in it, because entailment doesn't hold between any set of premises and a conclusion. But that could be true, and then you could have some conditional like this, like if this entails this, then, and you claim something else follows. But because this is always going to be false, because nothing entails anything, right? Thinning comes out trivially true, right? So I think that you could be a nihilist in a very intuitive sense. You could think the entailment relation is empty, and you could still accept thinning, and you could still accept cut, right? But I think that person's a good nihilist, right? So when they say there are no logical laws, what they're going to mean by that is there's nothing of this form, all right? So this is what a logical law would have to look like. Would have to have kind of the turnstile, the symbol here, as the main predicate, right? So it's allowed to have nothing on the left, and it's allowed to look like this, but it's not allowed to be more complicated than that. All right, so the part where I tell you about the form of logical laws, this is the answer to that question, right? They look like this or like this, okay? But these don't count as laws. So if I end up with a view on which these things turn out to be true, it doesn't mean it's not logical nihilism, right? Because they aren't logical laws. Okay, second thought, well, you know, the logical nihilist says nothing that looks like this is true, right? And so now there's a question, what has to be the case for something like that to be true? Okay. And you might think, well, that's really easy. Don't you know anything about logic? You don't even know what validity means yet. But of course, once you know a little bit about logic, you realize that there were several competing definitions of validity or entailment, and you know, basically of this turnstile. So here are three, right? One thing people mean when they talk about entailment is kind of substitutional, right? So they say that for this to be a valid argument, it has to be that no matter what sentence I substitute for phi, and no matter what sentence I substitute for psi, it should be the case that if the left-hand side is true, then the right is as well, right? There's no way to substitute into these arguments, substituting the same thing here and the same thing here, that makes the premises true and the conclusion false, okay? So if that's what entailment means, then here's what logical nihilism comes to. There's always a way to substitute into any argument you like that makes the premises true and the conclusion false, okay? So that would be the nihilist view on the substitutional view of consequence. Okay, but not everybody likes a substitutional view of consequence. Here's a different way of thinking about it. When I say that this entails this, what I'm saying is that there are no cases in which all these premises are true and the conclusion is not. Okay, so now I explain what I mean by the turnstile by talking about cases instead of talking about substitution. And so if the nihilist understands consequence that way, then what they mean is there's always a case in which all the premises are true and the conclusion is not. Okay. And then finally, there's this much newer way of thinking about consequence due to Tim Williamson. He actually mainly just talks about logical truth, right? And he says if you have some logical truth, like say phi or not phi, okay, first thing you do is you replace everything that's not a logical constant with a variable, right? So same thing with same variable. So let me just put in a big X for those two things that were not logical constants, because disjunction and negation are both logical constants. And then you close the whole lot under universal quantification. Okay. So if you've just done first order logic, this looks pretty weird, because we're not quantifying into like a term position, like where you'd have a name or a like term type variable. We're quantifying into sentence position. All right, but on Williamson's way of doing this, this is allowed. And he says that the original thing, which was phi or not phi, that is a logical truth. just in case this thing is true. Okay. And of course, if we were thinking about consequence that way, we'd have to generalize it to actually think about logical consequence, not just about sentences and whether they're logically true. But then you could kind of see what the logical nihilist would say about this anyway. He would say that this universally quantified sentence is always false. Right? There's always some x such that, well, this doesn't hold, right, when you put that in. Okay, so I said I'd explain what logical nihilism is. I've given you 3 different kinds of logical nihilism, right, varying with 3 different kinds of logical consequence. And from now on, to keep things simple, I'm just going to work with a substitutional conception, right? So we're going to look at how to argue for logical nihilism, but we're always going to think of that as the claim that given some putative potential logical law, there's always a way to substitute in for phi and psi that'll make all the premises true and the conclusion not. Okay, so that's the logical nihilist view. And the first thing that I kind of want to say about it is I don't think it's self-defeating, or at least I don't think it's self-defeating in the way I understand the accusation. So maybe there's some other way that I haven't understood yet. But here's what I think people are usually getting at when they say nihilism is self-defeating. They're saying that in order to convince somebody of logical nihilism and persuade them of it, you would have to give an argument for it. Right? That argument would have to use logic. And so if it turns out, as the conclusion of the argument is there's no logic, then that undermines the argument for it, right? So what they're suggesting is you could never have a good reason to believe this view, because as soon as you started trying to believe the view, that would wipe out your argument, right? I think that's the idea that people are getting at when they say it's self-defeating. So I think this is wrong for 3 reasons, and I think probably the first one is the most important. Just because you don't think that something's a logical law doesn't mean you can't use it in an argument, right? We use all kinds of connections between things in arguments all the time, and they don't have to hold in virtue of logic alone, right? So suppose you're an intuitionist, right? So you have this particular view, maybe it comes from thinking about philosophy and mathematics, but you don't think the law of excluded middle holds, right? And the real reason you don't think it holds is there are some instances of phi, maybe instances that make claims about infinite collections, right? Such that you think you can substitute them in here and the result is not a truth, right? It doesn't mean that, when you're giving an argument some other time, maybe not reasoning about infinite collections, you can't say, well, look, either there's water in this jug or there's not, right? Or either there's water in this jug or it's not the case that there's water in this jug, right? And then reason from that, right? Even an intuitionist who doesn't think this is a law of logic can use it sometimes in arguments. Not this, but an instance of it, right? So even if, say, the logical nihilist doesn't think that modus ponens holds, well, that means they don't think it holds completely generally, no matter what you substitute in for phi and psi. They might still think that, say, this argument, snow is white, or if snow is white, then grass is green. Snow is white, therefore grass is green. They might think that argument's perfectly good. But still, they think there's some esoteric, weird sentence that you could substitute into modus ponens that would make all the premises true, but the conclusion not true. And so it's not a logical law, right? So, here's another thing to think about. So sometimes it's easy to confuse metaphysical laws, like metaphysical connections between things, with laws of logic. And so somebody who hadn't done very much logic, they might think every event has a cause, was like a law of logic, right? But, they do a bit more metaphysics, they do a bit more logic, they say, you know what, that's not really a logical law, that's a law of metaphysics, right? And they might think, yeah, I still get to use that in an argument. Doesn't mean that I'm appealing to some logical law or accepting that it's a logical law. Okay. So I claim that it makes perfect sense that the nihilists would be able to give some argument for their view. They would think that, say the premises are true and that none of the steps they made in the argument failed to preserve truth without thinking that the connection between those steps was logical entailment. Okay. Second thought about why it's not self-defeating. Well, there's more to giving arguments than deductive logic, right? So sometimes you can argue for views by like using inference to the best explanation or induction. And you can almost see how somebody could give kind of a bad argument for logical nihilism using induction. They could say, look, 100 years ago, people used to think classical logic was true, right? And there were all these laws that they accepted. And then, I don't know, Cleany came along and convinced them that, you know, not all those laws were laws, so we had to give some up. And then Graham came along and convinced us that even more of them weren't laws. And this logic project is a disaster, right? We just keep losing laws that we had before. So we shouldn't expect the future to be any different from the past, right? Conclusion, there aren't any laws of logic. We'll eventually get rid of them all. Okay, I'm not saying that's a good argument, right? But it's a non-deductive argument for logical nihilism, and so it's not undermined at all by the thought that the logical nihilist can't appeal to deductive entailment. Okay. I think that's it for the self-defeating view. Okay, so I promised you counterexamples to obvious logical principles, right? So I want to give you, to start with, something that would look like a counterexample to conjunction elimination. Okay, so what do I need? I need a sentence that I could substitute in for phi and substitute in for psi, like maybe a different sentence, such that this conjunction is going to be true, but phi on its own is not going to be true. Okay, that sounds really strange. It might sound impossible. Here's why it might sound impossible. Like, look, it seems like, given what conjunction means, in order for the left-hand side here to be true, phi is going to have to be true, right? But then just look at the right-hand side. All that's there is phi. So if phi has to be true, I'm not going to be able to make the conclusion fail to be true, right? Kind of two thoughts about how you might argue against something like conjunction elimination. One is you might mess with the semantics of a conjunction, right? So you might try to have a different conjunction, maybe some kind of weaker conjunction. Maybe you know, have some fancy stuff to do with like impossible worlds or weird things, but somehow you make it come out that this can be true and this is not. So one problem with going that way is you're really open to the charge that you've changed the meaning of this symbol, right? If you've, say, messed around with the rules for conjunction or the truth conditions in like your definition of an interpretation, then people are going to be tempted to say, look, what I said was correct, was conjunction elimination. You've like replaced this truth functor with some other truth functor that you're writing the same way, but it's not really conjunction. And so the thing you're giving a counterexample to is not really conjunction elimination. Okay. So because I'm kind of worried about that response, I'm not going to go that way, right? So I'm not going to approach this by messing with the meaning of conjunction. What I'm going to try to do is come up with some really weird thing that I could substitute in for phi that makes it plausible that phi here could be true and phi here not. And you think, well, how could that possibly happen? It almost seems like whether or not phi is true is going to depend on whether or not it's embedded in a conjunction. Right? So let's run with that idea, right? Let's invent a new predicate, and the predicate is going to be solo, right? And solo is a metalinguistic predicate, right? It applies to, well, you know what? I've missed out part of my argument. All right. I'm going to come back to solo. All right. So substituting into arguments, right? So we've got this conception of logical consequence on which the only way one of the things that looks like this comes out true is if you can't substitute in for phi and psi in such a way that this lot comes out true and this doesn't, right? When you're doing that, you have to be careful in a couple of ways. So one thing you have to be careful about is you need to substitute the right kind of thing in for phi, right? So we might have this argument here, but we could also have arguments, I don't know, for all x, pi x or not pi x, right? Where there are things in here that are non-logical symbols, but they're predicates, they're not sentences, right? So if I was substituting into this thing, I would have to substitute in predicates. And if I'm substituting in here, I have to substitute in sentences. So this is just sort of the simple point that the thing you substitute in has to have the right syntax. It has to be the right kind of expression. But then also the class from which you, and all my examples are going to be sentential just because that simplifies things. The class from which you substitute into here has to be big enough, right? So suppose I looked at this argument, right? So this is affirming the consequent, as it should be. If I then psi, psi, therefore phi, right? So I think this argument is not valid, right? It's certainly not classically valid, right? But if the only sentences I was allowed to substitute in for phi and psi were true sentences, right? If my substitution class only contained true sentences, then I would not be able to get a counterexample. Because I need to substitute in such a way that I make all this true and this not true. But if the only thing I can substitute in here has to be true, then I won't be able to do that, right? Okay, simple solution. I allow myself a bigger substitution class, right? If I'm going to capture the real logical consequences instead of this one, I have to allow myself at least sentences that can be true and sentences that can be false, right? So when I do that, I could say, okay, suppose we put a false sentence in here. It's going to be false there as well, but let's make this one true. And now, okay, all these premises are coming out true, but the conclusion's false. So now I get my counterexample, okay? But we still, making some pretty normal assumptions about the connectives. If the only sentences we're allowed to substitute are true sentences and false sentences, then, and they get one truth value exactly, just true or just false, then there are going to be other people who say that we haven't made our substitution class big enough yet, right? But in addition to allowing ourselves to substitute true sentences and false sentences, we should be able to substitute sentences that have no truth value, right? And if I do that, then I'll be able to get rid of these logical laws, right? So if this has the truth value just undefined, and so does this, and the way the conditional works is that this thing gets undefined, then it's possible to make this thing on the right come out not true, namely just undefined. And so these won't count as logical laws. Okay, but then a certain kind of person is going to say, you still haven't made the substitution clause big enough, right? Sure, you think you've got, say, maybe modus ponens and disjunctive syllogism, but you're not thinking about the cases where sentences can be both true and false, right? And now, when I talked about sentences being neither true nor false, I kind of waved my hand in the direction of some motivating philosophy. I said, what about future contingents? Or what about vagueness? Or what about failure of reference? Right, so now I'm going to wave my hands at some other philosophy. I'm going to say, what about the liar paradox? Right, so various people think that the liar sentence, this sentence is not true, is both true and false. Right, so it can have two truth values at the same time. And let's call that B for both. Right? And they're going to say, well, you should be able to substitute sentences that are both, like liar sentences, in for phi and psi. So let's suppose we do that. I'm going to put something, let's see, false in here, but then I'm going to make psi both, phi both. Okay, and now the way the conditional works is this is going to come out both, because true to false is false, but false to false is true, so this is both, right? And it's both here. And what do I have now? I have a situation in which all the premises are true. They're false as well, but they're true, right? But the conclusion's not, right? So, counterexample to modus ponens. I get to lose that from my list of logical laws. Maybe I'll symbolically represent that. Pretty much the same thing happens with disjunctive syllogism, right? I get rid of this, and you think, well, what do I have left? What do I have left is also something you saw yesterday. It's FDE, right? It's the why can't I think of the letters? FDE stands for
First degree entanglement.
the logic of first degree entanglement. Thank you. So, for example, I don't get modus ponens or disjunctive syllogism or any logical truths, but I can have some sort of familiar things that you almost think of as defining the connectives. So I could have disjunction eliminate or disjunction introduction. That'll do. So from phi, you can get phi or psi. I can have conjunction elimination like this. I can also have conjunction introduction. And of course, I still get to keep identity. Right? So I haven't shown you this. I'm just telling you about this logic. Right? I think that FDE is borderline logical minimalism. Right? It's so weak that you're not really going to be able to do anything very exciting with it. But it's clearly not logical nihilism. And so a natural question now is, can we get some counterexamples to conjunction elimination identity? All right, so now we're back where I'm going to try to give you counterexample, and the counterexample is going to use this word solo. And remember we were thinking, look, is there some way I can get the truth value of phi to kind of switch between the premises and the conclusion? Like, can I think of an English sentence or just any sentence such that it might be plausible that it does? Certainly, the normal sentences we use in logic don't work like this, right? But I think I could sort of make one that does. So let's say that solo applies to some atomic sentence or the negation of an atomic sentence if it's not embedded in a conjunction, right? We could even say if it's not embedded in like a binary truth functor at all, all right? So just as an example, this would be solo if I just had the sentence P on its own. And not P would be solo, because neither of those is embedded in a binary truth functor, but the P in P and Q is not solo, because now it's embedded in a binary truth functor. And we can imagine even that, you know, if the sort of immediate scope is not the binary truth functor, right? So this is kind of what's going on there. This gets negated and then it gets conjoined. This still counts as solo. Sorry, it still counts as not solo. Okay, so now imagine we have a sentence that uses that word and it says, this very sentence atom is not solo. And snow is white. So that's my premise. Here's my conclusion. This very sentence atom is not solo. Okay, here's what the nihilist is going to claim. They're going to claim this is a counterexample to conjunction elimination. Here's the argument. First of all, this is an instance of conjunction elimination. What you have as the premise is the conjunction of two sentences. And then what you have as the conclusion is just the first sentence repeated. However, they say the premises are all true. There's only one premise, and it's a conjunction. The right-hand side of the conjunction is true. The left-hand side of the conjunction says this very sentence atom is not solo, but that's right, because it's embedded in the conjunction. So that's true as well. And so the truth value of the whole conjunction is true. Truth value of the conclusion, they say, is false. Because that says this very sentence atom is not solo, but it is solo. Because it's not embedded in a conjunction anymore. Okay? So this is false. True premises, false conclusion is an instance of conjunction elimination. So they say this is a counterexample to conjunction elimination. If you widen your substitution class far enough that you're allowed to embed sentences with weird predicates like this, then you can get a counterexample. Okay, there are things that somebody who doesn't want to be a nihilist might say to respond to this, and I'll come back to those in a minute. But I also wanted to make it clear that if I'm allowed to make this kind of move, I can get counterexamples to identity as well. All right. So for identity, imagine this. Here's my premise. This is the first occurrence of this sentence type on the board. Okay, that's the premise, and then, since this is an example of identity, the conclusion has to be exactly the same, right? This is the first occurrence. Okay, nihilist arguments. This is an example of identity. What they will say is we've substituted the same sentence in for phi on both sides, but because of the placement in the argument, this top sentence is true because that sentence doesn't appear anywhere else on the board. This is the first occurrence, but the conclusion is false. All right, so I say that to make it plausible that if we're going to allow this kind of argument, we can get logical nihilism. Right? Just about anything, we can get a counterexample to even identity. Okay. What might somebody who doesn't want to be a logical nihilist say in response? Right? The obvious thing to complain about is there's some kind of ambiguity in these arguments. Right? So it's not clear that this very sentence atom in the top of the argument means the same thing as this very sentence atom in the bottom of the argument. Right? And there's a traditional thought that if the meaning has changed, then it's not an instance of conjunction elimination, right? It only looks a bit like one, right? Problem is that it's not a straightforward example of meaning change, right? So it's not like I said, the bank is wet, therefore the bank is wet. And in the top part, I meant the riverbank. And in the bottom part, I meant the financial institution bank, right? So that there was like two clear meanings for one word. Because unlike with like bank, which is clearly ambiguous, this very sentence, you might think it means the same thing in the top of the argument as it means in the bottom, okay? It's the same English words, right? They're not interpreted differently. It's not like atom here means part of the sentence and atom here means part of a molecule or something like that, right? It's not ambiguity like that. The best argument for saying that the meaning has changed is to point out that the referent has changed, right? The particular object we're picking out. So this very sentence atom here picks out like this sentence atom. And this very sentence atom here picks out a different one, like a different token of that type. And one thought is that meaning determines reference. And so if the reference changed, the meaning has to have changed. Right? But, and so kind of what this line of argument would be saying is we haven't uniformly substituted into the conjunction elimination, right? Because we've changed phi from here to here. Okay, but here's a different tack you might take, right? All that's required for uniform substitution is that you substitute something that's syntactically identical on the left and also on the right, okay? When we do logic normally, that's perfectly sufficient, right? We don't, we usually deal with formal languages in which keeping things syntactically the same, like the same string of characters, is sufficient to preserve whatever kind of meaning we're interested in, okay? And then when we start to introduce symbols for which that's not the case, like maybe even if we start to look at indexical logics where we use words like I and tomorrow, right? Then there's the question like, when have you substituted in uniformly, right? And one possibility is you could be really strict about it. You could say, have to have the same reference, right? That's what the traditionalist is going to push. But it's not really dictated by the way we've done things before, because we haven't really dealt with this kind of stuff before, right? So here's another possibility. You might have to have the same linguistic meaning, or what's sometimes called the same character, okay? But it's often thought that like, I, the first person singular, or tomorrow, they have the same character, but when you use them in different contexts, they pick out different things, right? So there's a sense in which they have the same meaning, no matter which context you use them in. But then there's another part of the meaning, like maybe the content or the referent, that changes, right? And so there's a question about what you mean by uniform substitution, right? Syntactically the same plus linguistic meaning, right? And in that case, it's sort of plausible that you have preserved linguistic meaning from the top to the bottom. Syntactically the same plus linguistic meaning and content. Syntactically the same plus linguistic meaning and content and referent. Okay, so what I mean to suggest to you right now is there's a lot to argue about here. And it might be that you don't want to go with the answer the traditionalist gives. There may even be some arguments that have some sort of pull as intuitively valid that require the referent of some expression in them to change. Right, so here's an example I got from Tim Williamson. The argument goes, it is now exactly midnight. Therefore, it is not now exactly midnight. Right, to get the intuitive feel for that argument, it's like, if the premise is true, if when you say the premise, it is exactly midnight, then by the time you get around to saying the conclusion's false. Even though that's an instance of identity, right? Sorry, it's not identity, right? Okay, anyway. Okay, what is false is that it's now exactly midnight, and the conclusion is it's not now exactly midnight. So the conclusion is true, but it's only true because the referent of now has changed. All right. So if you feel any intuitive pull at all to that kind of argument, then you might want to see if you can capture it formally, right? And if you want to do that, then you'll have to allow some kind of referent change between the premises and the conclusion, even if you keep the linguistic meaning the same. Okay, so I want to suggest that there are more possibilities open to us than just always keep the referent the same, and that there might even be good reasons for taking other possibilities. Okay, so here's the situation we're in. I have given you a couple of really weird counterexamples, right? And the nihilist wants to say, yep, these are brilliant, let's get rid of logic, right? They like the counterexamples and they want to defend them. And the traditionalist wants to say, no, there's something wrong with these counterexamples, you're being stupid, we get to keep our logic and you don't get rid of it that easily. All right, so I am reminded of this situation in geometry that happens in a dialogue by Lakatos, where he is talking about a theorem, and it's a nice theorem, and it's got a proof, and then it seems to have some weird counterexamples. So what I'm going to do now is I'm going to tell you about this theorem. So the theorem is about polyhedra, so things like cubes and pyramids and sort of three-dimensional shapes like that. And what it says is, let me just make sure I get it right. I've written down here somewhere. Yeah, okay. So the number of, oh, I've got two colors. Okay, number of vertices minus the number of edges plus the number of faces equals 2. All right, here's an illustration. We pick a polyhedron, so maybe I could attempt to draw a pyramid on the board. So this is like a pyramid with a triangular base. So I can put that in. Okay, and the number of vertices, that's like the number of corners. So I've got 1, 2, 3, 4, right? Minus the number of edges, 1, 2, 3, 4, 5, 6. Plus the number of faces is 1 on the back, 2, 3, 4. And, oh wait, there is 2, right? So it works for this one. Okay, and we can try that out with a few other simple polyhedra, like a cube and things like that. And they do this in the class, right? They go through a few shapes, and it turns out that the answer is 2. And so it sort of naturally raises the question, is the answer always 2? Like for any polyhedron? And the teacher gives them a proof that it is. Okay, I'm not going to go through the whole proof, but the beginning of it's kind of cool, and I want to use it later. So here's the beginning of the proof. So take your polyhedron and imagine that it's made out of a rubber sheet, right? So it's made of rubber and it's hollow. And then you're going to take a knife and you're going to cut out one face from your polyhedron, right? So now there's a hole on the side of the polyhedron, and this is why it has to be made of rubber. You're going to take what's left and you're going to stretch it flat onto the plane. Okay, so in the rest of the proof, you get to like cut out various triangles and count things, and it ends up showing you that this has to be the case. Okay, and And so it seems like we're in this nice, neat situation, right? We came up with this conjecture. It seems kind of beautiful. It worked in a few cases. And then the teacher came up with a proof that it always works for any polyhedron, right? So now we have a proof, and so we've made progress in geometry. And at this point, the students start to suggest counterexamples. And actually, I have a couple of quotes from the students in here that I want to read to you. But here's one of the counterexamples. They say, suppose you have two cubes, one nested inside of the other one. Right, so if you kind of imagine a cube cut out from the inside of another cube. Or they say, suppose you have a big cube and a smaller cube, and you stick one onto the side of the other one. And they say, count up the vertices and the edges and the faces, doesn't work anymore. Or they talk about a picture frame shape as well, where there's like a hole cut out of the middle, right? And then you count up the edges and the vertices and the faces, and it doesn't work anymore. And some of the students think this is brilliant, right? They're like, these counterexamples are awesome. We're going to get rid of that theorem. That's the end of geometry. Or that's the end of what the teacher showed us. Right, so here is student Gamma. The students all have exciting names like Gamma and Delta. So Gamma says, sir, your composure baffles me. A single counterexample refutes a conjecture as effectively as 10. The conjecture and its proof have completely misfired. Hands up. Right? So the teacher's supposed to surrender to the counterexamples. But there's another student who hates the counterexamples and loves the proof, right? So the student Delta says, but why accept the counterexample? We proved our conjecture. Now it's a theorem. I admit that it clashes with these so-called counterexamples. One of them has to give way. But why should the theorem give way when it has been proved? It's the criticism that should retreat. It is a fake criticism. This pair of nested cubes is not a polyhedron at all. It's a monster. A pathological case, not a counterexample. All right, so I hope you can see the parallel with my nihilist and the traditional logician who wants to resist the counterexamples. So the nihilist is like student Gamma, who wants to accept these fancy counterexamples and give up on the theorem, even though it's been proved, which is sort of weird, right? And student Delta is the traditionalist who wants to protect their theorem, because after all, it's not like we don't have a proof of the log excluded middle, right? Or modus ponens, right? We do, which is sort of puzzling. And they say there's something wrong with the counterexamples, right? And it's clear right now that we could take either of these two options, right? And we could probably argue for them and do a relatively good job, except that the teacher doesn't think you should do either of these things in the case of geometry. He thinks you should do something different, which I'm going to tell you about now, and then I'm going to suggest we do the same thing in logic. Okay, so the teacher says that he doesn't really like the view where you just give up on the theorem completely and accept the counterexamples, because it's sort of puzzling, like what went on with the proof. I mean, you can't prove things that are wrong, right? So, you know, what happened there, right? And secondly, of course, we did quite a lot of work, or at least the Lakatos's imaginary class did quite a lot of work coming up with this theorem and the proof. And it seems such a shame to throw away all the insight that we got from thinking about those things and just be left with nothing. But on the other hand, he doesn't really like the kind of sticking in your heels and insisting on the theorem, even in the face of these sort of interesting counterexamples either. And one of the reasons is, like student Delta, when he's asked, like, why is this not a polyhedron, like the nested cubes or cubes stuck together and things like that, he has to start coming up with like refinements of the definition of polyhedron that makes it clear that they're not polyhedra. And the definition of a polyhedron starts to get so complicated and so kind of obscure that it becomes really implausible. This is what we were talking about in the first place. All right, this was sort of anything like capturing the intuitive idea of a polyhedron. Similarly, you know, you might think if you're going to keep redefining uniform substitution to get around various counterexamples, it's not all that plausible that we've definitely had this thing in mind right at the beginning. And also, if that's what you do and you hang on to the theorem at all costs, you don't get to learn anything interesting from these weird examples, right? So you don't get to say, develop logics in which things go differently. Okay, so here's what he suggests we do instead. We use this process called lemma incorporation. And the way that works is this. First of all, you have to lay out very carefully the proof of the theorem that you found. Right? So you write it out in great detail, you don't miss anything out. And then you look at your monstrous example, right? Your weird counterexample, and you figure out what about that weird counterexample you didn't take into account with the proof, right? There'll be something in the proof, some assumption that is violated by that counterexample. So think about the counterexample that's like a hollow cube cut out the inside of a bigger cube. And suppose we're going through the beginning of this proof again, and it says, okay, first of all, get your knife out and kind of cut off one of the faces from your polyhedron, and then take the rest and stretch it flat on the plane. If your polyhedron was one of these nested cube examples, you won't be able to stretch it flat, right? You're not going to be able to get it to go flat on the plane. And so that's the assumption that's violated by that counterexample, right? The assumption that you'll always be able to stretch the result flat on the plane. All right, and so now what you do is, having found the assumption that was violated, you build that into the statement of the new theorem, right? So the assumption that was violated is that, say, this was a simple polyhedron of a certain kind, that it could be stretched flat on the plane with one surface gone. And so now we say something like a simple polyhedron, right? And then we still have the rest of that theorem. It's just that the domain in which it applies is more restricted now. Okay, you do this in response to counterexamples, but it's not ad hoc in the traditional sense of ad hoc, because you don't just restate the theorem and say, except for that one counterexample that we came up with, right? Because that would leave us like totally puzzled about the whole thing, right? We'd have a proof of some really general thing, and then we have this extra exception tacked on the end. There'd be no explanation of why that was an exception, right? But when we go through the proof and figure out what lemma was violated by our counterexample, and then we build that into the new theorem, then it all hangs together a bit better. We can see sort of what's going on, and it even suggests like new avenues for research. So if simple polyhedra behave a certain way, they have a certain Euler number, there's a question, well, what about the ones that are not, right? What about some of these counterexamples? Are there any like uniformities in how the vertices, edges, and faces are related? Okay, so thinking that works pretty well in geometry, seems nicer than the other two options, could we make it work in logic? Okay, I'm going to use the law of excluded middle, I think, as an example. Just because, proving identity is so short and it's almost, it's hard to get the proof going, and so we don't have much to work with. But suppose we've got a proof of the law of excluded middle. And you think, well, how does that go? Well, you say, look, there are two possible situations, right? So there's like case one and case two. And you're like, okay, case one is what if phi is true? So you say, okay, phi is true, and case two is phi is false, right? And then you go through and you've got your truth clauses for disjunction and stuff. So, okay, phi is true, then it follows from the truth clause for disjunction that phi or not phi has to be true as well. Great. If this is true, if this is false, then it follows from the truth clause of negation that this has to be true. And then we use disjunction again and get phi or not phi. All right, I'm supposed to do this, in great, great detail. So, imagine I've written in some more sentences and sort of a bit more explanation. But then we get this counterexample, which is this one here, where we say, okay, so this situation where the truth value of phi is undefined, what's happening? Well, it turns out the truth value of the whole thing is undefined, right? That was our counterexample. What stage in our proof violates the is violated by this counterexample? Well, it's the stage where we said, these are all the cases, right? We said it could be that phi is true, or it could be that phi is false, right? And then eventually down here, we get the conclusion that this is going to hold either way, right? Okay, so here's a thought you could have. The assumption that was violated was that the sentence was either true or false. So you might say, for sentences that can only be true or false, right? Or maybe more, shorthand for bivalent sentences. This is a logical truth, right? And of course, the sentence that has no truth value isn't a counterexample to that because it's only claimed to hold for bivalent sentences. Okay. So you might think, well, how would it work with some of our other counterexamples? Well, in order to get counterexamples to things like conjunction elimination, we needed these funny kinds of metalinguistic predicates that meant that a truth value varied depending on whether something was embedded in a conjunction or not. There's lots of language that doesn't work like that, right? Where truth value doesn't vary, or the extension of the predicate even doesn't vary, depending on where something is in the rest of the sentence, or even where something is on the page. So you might call sentences that don't have these weird features, like stable sentences. And then you could say for stable sentences, which is sort of presumably what the traditionalists had in mind all along anyway, right? Identity is a law of logic, and conjunction elimination is a law of logic. Then you don't have to just stick your heels in, but you don't have to give up on logic completely. That is, you can accept these counterexamples are interesting and you can learn something from them, but you don't have to be a logical nihilist. All right, thank you.
We shall open now the floor to comments or questions.
Thank you for your presentation. It was pretty good. It's clarification. If I understood correctly, this position, the logical nihilism, challenges only logical monism or also logical pluralism? Because if I understand correctly, pluralists would say, well, yeah, maybe there are not these super laws, but the laws of logic are relative to a system.
Yeah, so the way, you remember the argument right at the beginning, there was like a sketch of an argument for logical nihilism, and it said, logical laws have to be perfectly general, right?
Yep.
No potential logical law is perfectly general, so there aren't any, right? Where the nihilist and the pluralist come apart is on that generality. So the pluralist says, they don't have to be perfectly general. We could look at what works in these cases and what works in these cases. And so they get different logics for different cases. And the nihilist, you can imagine them saying, you're not allowed to do that in logic. Logic has to be perfectly general, but they still accept these like interesting counterexamples, and so they end up with nothing. So I think there's kind of a parallel with a physicist who says, laws of physics have to be completely determinate, right? That's what we expect of laws of physics. And then suppose it turns out that we can't find any determinate laws. We can only find these indeterminate connections. And instead of saying, let's study these indeterminate laws, these indeterministic laws, right? They say, okay, physics is impossible, right? So it's like Einstein, but even more stubborn, right? If what you really care about is like learning about patterns in truth preservation or learning about like regularities in the physical world, then the most sort of fruitful, interesting track to go is to give up on your conception of what a law had to be like and to allow it, sort of relax it a little bit. And then you can still study patterns in truth preservation without assuming they have to hold absolutely everywhere. So this is a kind of logical pluralism. The view that I'm pushing you towards is suggesting that I guess the logical laws might vary with language. And if you keep the language of truth functional logic, so people say propositional logic, with the thought that sentences can be true or false, but not both and not neither, you get to keep classical truth functional logic. But its domain is restricted to that. Yeah.
When I found out this question when I read your summary, it's like a presupposition behind your talk. Something quite important. What is the notion of correctness that you are using? Yeah.
I mean, truth of a sequence. So,
okay. So you are a realist on
about truth?
yeah.
Yeah, sure.
Okay.
Okay.
So then what would be like the difference from you, between your position and the logical relativism?
Huh. So, some people, when they talk about pluralism and relativism, they seem to have very, very clear ideas about what one is and what the other is. And somebody might put forward a pluralist position, and somebody else says, that's not really pluralism, it's just relativism. I never quite understood the difference. All right. So one way to think about my view is it means that validity is relative to, say, language or certain features of language. And another way to understand the view is there are several correct logics. That correctness happens to vary with language, and you might say that's pluralism. I don't really mind if you want to describe it the relativist way instead of the pluralist way. Do you have strong opinions about how the words pluralist and relativist should be used?
Well, it's just that the one puts the emphasis on the number of logics, and the other on the foundation of what is it to be considered as logical.
Yeah.
So
you could be
it's
both.
good to have them on different axes, no?
I mean, I don't mind where you want to put the emphasis, as long as I get to keep the view.
No, it's not about an emphasis. Just there, like the metaphysical acts and the numerical acts of how many logics are correct. So we don't need to conflate like logical realism with monism.
I thought we were talking about relativism and pluralism.
Yeah, but it's the same. I mean, historically, for example, Susan have been accused of conflating that, but what comes after not conflating that is like separating the axes of how many logics are correct from the question of what is it to be considered like logicality as to decide what is the foundation of for theory to call logic or not.
Yeah, so I guess I just don't care that much about whether it's relativism or pluralism. So it's clearly relativism in some sense, that it's relative to language. And if you ask me how many correct logics there are and you don't specify relative to a particular language, then I think it's perfectly reasonable that somebody could answer more than one. So that looks like pluralism. Okay.
Do you see any advantage in defending logical nihilism for the studies of philosophy in general? Or do you see it as doom?
So, for philosophy in general, so not just logic, but gosh. So I don't know, I haven't really thought about that question, but off the top of my head, I suppose I mean, one advantage might be helping to clarify the distinction between, say, logical validity and other kinds of truth preservation that aren't guaranteed in virtue of logic. And it might help some philosophers who haven't thought much about logic to see that they can make arguments without it, say. And they may not be logically tight, right? There may be some circumstances where the premises will be true and the conclusions false, or some substitution instances.
It opens the field.
Yeah, I think it opens more possibilities, and possibilities for maybe sometimes doing things without logic. But mostly with logical nihilism, I'm worried about it being sort of destructive. You know, there are projects that use logic, and you know, some of them seem creative and interesting and promising, and I'd like to see them, you know, developed. And logical nihilism almost seems like it would stop them before they really got going, and that would be a shame, I think.
Come back.
I've got a question concerning the charge of self-defeating against logical nihilism. And if I understood you well, you said that the logical nihilist gives arguments in favor of this position. And at the same time, he can use these logical laws, if we want to call them logical laws. But I think the problem is not if he can use these laws. The problem is how can he justify his position. He can use the laws, of course, but how can he justify the use of these laws if they are not universal, they are not really laws? It seems to me that it's something analogous to the case where I can justify a moral act by saying, okay, it's allowed for me to use this law, but not for anybody else. That's my question. I think it's...
Okay, so I think you're right about what I'm saying. So I'm saying that they can still use instances of, say, the law of excluded middle, even if they don't think it's a logical law. But the point is not that it's not justified at all. It's just not justified in virtue of logic. So they might think that, say, there's water on this vase or there's not. It's true. For perfectly good reasons, like, for example...
not logical reasons. I mean, maybe another...
They can see it.
The problem is that logical reasons seems to be universal, and when I say that those reasons are not logical, they are not universal, and then...
But you don't need them to be universal, you just need them to hold in your case, the one you're interested in. So when the intuitionist uses an instance of the law of excluded middle, and it's not for some infinite class, right? They're just saying about this pen's black or it's not, right? Then this is a case in which they think, for these instances, they might even say the law holds, right? That's a weird way to put it. But because there are some substitution instances where it doesn't, they don't say it's a law of logic. Okay.
Luis?
Yeah, thank you. You decided not to mess with the meanings of connectives.
Yeah.
But decided to mess instead with the meaning of
Predicates. Yeah, or sentences, yeah.
Indexicals. And then you appeal to the idea of meaning as character. And as you probably know, some logical nihilists like me would talk of something like the character of conjunction and all the other connectives in order to provide the right counterexamples to the laws, in particular to conjunction elimination. Could you say more to prepare your option?
Yeah, so I don't know that I know the counterexamples you're thinking of, but when you start talking about the character of conjunction, I mean, for that character to be interesting, you'd expect it to have a different content in different contexts. Is that the idea?
I would separate the type of the truth function and the content of the truth function.
Okay.
The exact number of values and the order between them. That's kind of...
Okay. And do you think that you've changed the subject? That's what I was worried about, that way of getting counterexamples, right? Was somebody would say, that's not the rule I was talking about. I was talking about conjunction elimination.
Present just the same truth condition, and in order to say that it has to work classically, then they have to give me more information. For example, 2 values with the usual order, and it's not just the truth condition.
Okay. So I suppose you actually think they got the character wrong, right? And they only captured it in, say, one context. And so you think there's been no change in meaning? I think that's quite promising. I mean, I didn't go down that path, but I didn't think of that way of responding to the objection either. So yeah, it'd be interesting if that was another way of getting to the same counterexamples, or different counterexamples to the same theorem.
Axel?
There seems to be a tension between your final between your final position, that I like a lot, actually, but and your reply to why it is not self-defeating. And I think that what you need for it to not be self-defeating, you lose when you put it the other way. Because as I understand it, your final response is that these laws that seem to be no longer laws, once we properly relativize it, once we give them the proper domain, then they're actually universal. So somebody can say,
Well,
that pretty much is your reply. Why am I getting it wrong?
yeah, so I think of this as being the claim that they're not universal, right? That you've restricted it to the domain. So for
that is part of the law, right? So
yeah, I mean, the nihilist is going to say these have the wrong form to be laws, right? So the nihilist is going to deny that my laws are laws, right? Because they don't have this form or this form. They have this stuff at the beginning that says, if you're dealing with these kind of languages, blah, blah, blah.
But when would they say? I mean, that does seem a little ad hoc, since we do have like normal, just first order logic has these restrictions on like universal generalization. So our logical laws don't have that form. We have these extra requirements already in just what we normally call logical laws. So the ones that you're going to get now, I think they would have the same kind of restrictions.
So we're thinking like universal introduction in particular and existential elimination. I really hadn't thought about that and what the nihilists might say about that. So let me get back to you because I don't know what to say. Thanks.
Yes. In an open field in philosophy now that we cannot rely on logic, in what can we rely?
So my conclusion is not logical nihilism, right? My conclusion is a way of rescuing some of the more interesting, important work we've done in logic so that we can still use it in philosophy. So, so there's sort of this question about, can you use the log excluded middle in philosophy? That really depends on what you think about the truth values of sentences. So you're not going to be able to have logic tell you this alone, right? You're also going to have some philosophy of language or some theories about truth that tell you, say, you have a sentence like snow is white. Can that sentence have no truth value? Or is that sentence always going to be either true or false? Maybe you think that, say, if you have an atomic sentence, the only way you're going to get it to be both true and false is through some sort of metalinguistic trickery with like the truth predicate. And maybe you think like a simple sentence like snow is white can't be both true and false, right? I don't know. So there's different like philosophical views you could have about it's really stuff in philosophy of language, stuff about truth values and, what's the best solution to, say, paradoxes associated with vagueness, or what's the best way to think about future contingents. And there'll be more to it, I assume, than just what it does to your logic, right? You'll also be interested in like your theory of time or your, theory of other kinds of expressions, how you solve other sorts of paradoxes. And it means that you still have a lot of work to do to answer that question, right? But it's not like once you've done some of that work, you won't be able to like use logic to help you get further.
Well, yes.
I was wondering whether or not there is more than one way to provide a counterexample for the logical laws we know. I mean, when you provided those two counterexamples, the solo counterexample and this is the first instance of this sentence, they both use context-sensitive words.
Yeah.
They depend on position, they depend on whether we read them first or second, things like that. They are not quite the exact same whenever we put them. Is there any other different way in which we may provide a counterexample?
So I think it's a little easier if we use a formal language and we're just allowed to like define up whatever predicates we like. So normally when I give the truth clause for an atomic sentence in first order logic, right? So let's just suppose I have just one name and one unary predicate, right? So if I put them together, I get an atomic sentence, right? And normally I say that, say, f of A is true just in case the extension of A falls within the extension of the F predicate, right, on this particular interpretation. I could allow myself, like, more complicated predicates whose extension can vary with position in the sentence. So when I give, say, the extension of, in fact, you know, it doesn't even have to be position in the sentence, just allowed to vary, right? So, but maybe there's like left of the turnstile and right of the turnstile or something like this. And then the interpretation of the predicate, instead of being a function from the domain to some subset of the domain, could be from the domain and a position to some subset of the domain. And it varies depending on whether you've gone with left or right. And then when you, so the only thing you've varied is the definition of the predicate. So you don't have a name that's shifting referent anymore, but you do have a predicate, so there's some extension shifting, but why shouldn't we have extension shifting predicates? They can shift their extension with that kind of thing, but then it's going to work in such a way that when the atomic clause brings them together, the sentence is true with the left variable, but false with the right variable. And you get your counterexample that way. It's more artificial, but it's cleaner, I think.
Please.
Suppose you apply the technique of lemma incorporation in the way you suggest. Okay. So suppose your inference is A, therefore B, and you've got this counterexample. So you figure out the lemma you need to incorporate, so it's A prime. Then you ain't got A, therefore B, but you've got A prime, therefore B. So it looks as though, prima facie, you've got your indefeasible law back. Now, the obvious thought there is, well, maybe you can do the same thing, okay? So you're going to have a counterexample A prime, therefore B. So you repeat the method of lemma incorporation, and you've got A prime, A double prime, therefore B. Okay, now, question, is this going to go on forever? Okay, it certainly looks like it's going to be harder and harder to find counterexamples. However, if the thing stops at some stage, you've got your indefeasible argument back, A prime, A prime, blah, 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 therefore B. So that's one possibility. The other possibility is that this really does go on forever. And then you're sort of in the situation that you get to in conditional logic, where I've got a conditional that appears to be true if A then B, and then there are all these sort of strange things I'm assuming, you know, I don't die tonight, I'm not invaded by Martians. Often people who say, well, life is too rich to have a single condition which you can add to the antecedent, which will entail the consequent. And what you do there is you say, well, yeah, but it's ceteris paribus. Okay? So even in this case, you've got some kind of law of the form ceteris paribus. If A and maybe some other junk, then B. So I mean, either you've got an indefeasible law back if the regresses terminate, or you've got a kind of a ceteris paribus indefeasible law. So one way or other, you seem to get these indefeasible laws back.
Okay, so first to like concede one of the things you're pushing for that I think is totally right. Like, there could be another counterexample that's not taken into account by this. So just like in the geometry case, we take account of the nested cubes counterexample, but then we find a new counterexample to our new principle, right? And the Lackintosh method is to reapply lemma incorporation, right? So you figure out what's special about the new counterexample and you readjust your theorem. I think that when we do this in logic, we end up with something that doesn't fit the form of the law that the nihilist demanded when they demanded, you know, perfect generality. So they were saying that a law.
The universalist.
Maybe, but certainly the nihilist expected laws to look like this, right?
Okay.
So turnstile is the main connector, right? And what I'm imagining they do is they add this metalinguistic thing. It's at the level of the turnstile, where they say for the following kinds of sentences, then this entails this, right?
What's object theoretic and what's meta theoretic is a movable feast. Okay. The point is, you've got some condition you can add as an extra, as an employmatic premise. It might have quotes, it might not, I don't know. There's got to be something you can add, which would seem to be initially logically sufficient when added to the premise to give you the conclusion.
See, I'm not sure that that's the case, right? So my language, my object language might just not be rich enough to specify the conditions, right? So maybe it doesn't have a truth predicate, right? And then I can't say if every sentence, maybe it can't.
It just means that the thing, your language isn't expressively complete. And of course, if your language isn't expressively complete, all sorts of things can go wrong.
Also, if it's expressively complete.
Yeah.
Okay. So one thought was I might eventually run out of counterexamples. That's kind of the happy thought about the future of logic, right? Or about geometry, right? There is uniformity to be discovered out there, and we gradually figure out where it holds and where it doesn't.
That's what maths are still.
Yeah. Okay. So I find that pretty plausible for logic and the languages as well. But say I'm wrong, right? Say truth preservation is sort of inherently chaotic, and I won't be able to. Eventually, I won't be able to find a condition that gives me something true. Or I guess, I mean, you were even thinking that the process would just go on forever. I keep finding new conditions, and I'm never.
Well, I don't see any reason a priori, I suppose, it must either terminate after a finite time or go on forever.
Okay, so
that's why I gave you the disjunction.
I mean, it seems like there's a parallel with ordinary science here as well, right? So my current theory is always just my best theory so far. And I've got reasons for thinking it true, you know, that it's confirmed by the evidence. I have my argument, but I'm not infallible. And
I don't think that's quite the analogy. The analogy is if you look at a law of nature, it always comes with a kind of ceteris paribus condition. And usually physicists express this as the system is closed.
Although...
Okay, so the law is a law provided the system is closed. Or however else you catch the ceteris paribus condition. So you might do something similar in your case.
Yeah, I mean, can I say like ceteris paribus Newtonian mechanics is true? Like, ceteris paribus F equals ma? Like,
ceteris paribus.
that seems kind of misleading.
Well, that's the way that physicists understand these things, right? Because they know damn well it doesn't work if the system is not closed.
I mean, they don't often say ceteris paribus Newtonian mechanics is true. They say actually it's false, but it's kind of useful.
Well, yeah, but even Newton realized that you could only apply his laws of motion in a closed system. So the law, law is conditional. The conditional is, provided the ceteris paribus condition is satisfied.
So no alien invaders and and then it's still false.
Well, we think it is now, but that's not the point. The point is just that whatever you take a law of nature to be, even the relativistic stuff, it's always going to be ceteris paribus.
Okay, so a couple of thoughts. The ceteris paribus seems to be different from something that would rescue it from one of these counterexamples, right? So when it turns out that things work differently at different speeds, right? We don't just say, oh, everything wasn't equal, right? We say, oh, there's some much more uniform theory that's going to explain it all. And when it turns out that for certain expressions, this just doesn't work, say some little excluded middle, right? Then we don't just say ceteris paribus, it's right.
No, we build in some kind of closed world hypothesis. There's no funny business going on.
The other thing that I wonder about is maybe the ceteris paribus stuff is legitimate describing physical systems, but we sort of expected logic to be cleaner.
Well, we apply it in the case of conditional logic to handle the two phase conditionals. And, you know, a statement of validity is really a big fat conditional.
Yeah, I don't like it very much, but I mean, I don't have more to say about that, except that it doesn't fit with my conception of what logical laws are supposed to be like.
Well, I mean, you could just accept conversion and say, yeah, this is going to make everything defeasible.
Oh yeah, no, I do accept that.
So
sure.
non-defeasibility is gone, but you can still have a defeasible inference pattern, and that strikes me as a sort of stable position.
Well, so there's two senses of defeasible there, right?
Non-monotonic.
Yeah, I didn't mean that. So okay. I mean, my theorem is defeasible that for such and such expressions, the lowest good of middle holds, right?
Okay, no, I meant
because I might find another example of that expression that doesn't.
What I meant is that all inference is non-monotonic.
Yeah, so I still have more hope for logical laws than that. I think we might be able to find something out. Okay.
Well, we've run out of time, so please join me in thanking our speaker today.
Thank you.